Okay, let's take a look at rectangles and squares. So first, a rectangle is a quadrilateral. It's a four-sided polygon, but it also is a parallelogram. Remember, a parallelogram is a four-sided polygon that has two sets of parallel sides, two sets of congruent sides. It's got diagonals that bisect each other. It's got consecutive angles that are supplementary. Remember, all of these things down here is a reminder of how to prove a quadrilateral is a parallelogram. So all of these things are true for parallelograms. But then rectangles have an additional quality, right? So a rectangle is a parallelogram, but it's a parallelogram with all of the angles are congruent. And if all of the angles are congruent, then all of the angles are right angles, which means all of the angles are 90 degrees. And it's got diagonals that are congruent. Remember, in a parallelogram, diagonals bisected each other, which means they hit at the midpoint. And that's still true for rectangles, because anything that was true for a parallelogram, meaning these properties, is also true for a rectangle, because all rectangles are parallelograms. But not all parallelograms are rectangles. Only parallelograms with these additional qualities make it a rectangle. And so really, I guess the definition of a rectangle is that it's a parallelogram with four right angles. And it also is nice to know that the diagonals are congruent. The area of a rectangle is the same as a parallelogram. It's just base times height. In this picture, it's b times c. Base times height. Now, usually we say length times width. Length and width. But really, it's just base and height because it has to be, because a rectangle is a parallelogram, and parallelogram area formula is base times height, so that's what it has to be. Perimeter, of course, is just twice the length and twice the width, right? Boom, 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 and we know that. I think this is kind of a review. Oh, totally spelled width wrong. I don't know how I didn't catch that. That's kind of funny. I just saw that right now. Okay, so how do you prove something? Well, there's two really ways to prove something is a rectangle. Show me that all the angles are congruent, meaning show me the angles are 90 degrees. Again, how do you show that this line is perpendicular to this line? Well, you have to show me the slopes are opposite reciprocals. Remember, showing me that this is 90 degrees is showing me that this slope and this slope are opposite reciprocals to each other. Or if you wanted to prove to me that a quadrilateral is a rectangle, you could prove to me that it's a parallelogram, meaning you could do any of these six options and show me that the diagonals are congruent. So you could show me that this is parallel to this is parallel to this, and that diagonal are the same length. Remember, to show me things are congruent, side lengths, you need to show me that the Pythagorean Theorem says they're the same length. So you could do that. Most of the time, rectangles are going to be proved by showing me that these are 90 degrees. Okay, so that's what a rectangle is, and we'll do some problems here in a second. Okay, let's look at now a square. Okay, so a square is a parallelogram and it's a rectangle, but then it also actually qualifies under a rhombus, and we can talk about what a rhombus is kind of later. But a square has all angles are congruent and all sides are congruent. Again, it's got all the things about a parallelogram. It's got all the qualities that a rectangle has, and it's got an additional quality that not only it's got two sets of parallel sides, two sets of congruent sides, diagonals bisect each other, consecutive angles are supplements, and now it's got what rectangles have. It's got congruent diagonals. It's got diagonals that bisect each other like a parallelogram. It's got 90 degrees like a rectangle, but now it's got one more additional quality, and that not only are all the angles the same, but now we got all the sides are the same. Again, we can show that the area is just length times width, which is like s squared, right? Side squared. We can actually show that the area is 1/2 the diagonal squared, and we'll talk about that in a second, which is kind of fun. The perimeter, of course, is just 4s, right? 4 times the side length. Proving something is a square is really just showing me these things. showing me that all the angles are congruent and all the sides are congruent, which really is this, right? That's going to be the definition of a rhombus. All the sides are congruent and all the angles are congruent is really a rectangle. Again, so this, proving this and proving this is proving something is a square. And just as a reminder, I'm going to scroll up. How do you prove something is a rectangle? Just show me the angles are congruent. And how do you prove something is a rhombus? Show me that the sides are all congruent. And again, I got to remind you, showing me the sides are congruent is showing me the sides all have the same length. And that you're going to use the Pythagorean theorem for something like that. Showing me the angles are all congruent is showing me that they're all 90 degrees. Showing me that two sides are 90 degrees is showing me that these two slopes are perpendicular, which means they have opposite reciprocal slopes. So we have squares, which are same sides and same angles, and then we have rectangles, which do not have necessarily the same sides, but have all the same angles. And again, if all four angles are the same, then all four angles are in fact 90 degrees. Okay, so again, both of these, rectangles and squares, are parallelograms. All squares are rectangles. All rectangles are parallelograms. But again, not every rectangle is a square, and not every parallelogram is a rectangle. But all squares are rectangles. All rectangles and all squares are parallelograms. All parallelograms are quadrilaterals. Okay, let's go through some problems that you might, run across in this section. Okay, so let's just see if I can get this centered. Okay, let's just do some kind of fun problems. What if I told you that you had a square, and let's say its area was, we'll just say 20 square feet. What could you tell me about it? Well, I think you could say something like this, right? If you know that the area is 20, then don't you know that 20 equals x squared, which means x equals the square root of 20. And we write that as 4 times 5, so that our side length is 2 radical 5. Okay, so I know the side length. So then what's the perimeter? So if the area is 20, then the perimeter is going to be 4 times 2 radical 5, which is 8 radical 5, and again that would be in feet. This would be in feet. So if I know the area of a square, I know the side length, I know the perimeter. What about the diagonal? Right? What about this distance? And so you say, well, that's just the Pythagorean theorem. So that would say that x squared plus x squared equals, we'll call it c squared. So that's 2 radical 5 squared plus 2 radical 5 squared equals c squared. Remember, when you square something like this, you have to square both pieces. So squaring 2 radical 5 is squaring the 2 and getting 4, and squaring the radical 5 and getting 5. So 2 radical 5 times 2 radical 5 is going to be 4 times 5, which is actually 20. So both of these are 20. So that's 40. And then the square root of 40 is going to be 4 and 10. And I get 2 radical 10. And someone's like, oh, did I really need the Pythagorean theorem? Remember, I understand 45, 45, 90, 90 triangles. That if I know that this guy is 2 radical 5, the diagonal, remember the diagonal in a 45, 45, 90 triangle is the square root of 2 times bigger. What's the square root of 2 times that? Is just this. And so actually I have the exact same thing. So I can save myself a lot of step on squares. Square side lengths and diagonals are pretty easy to show one or the other. Again, if I know the side length, I know the diagonal is the square root of 2 times bigger. If I know the diagonal, I can go backwards. So in this instance, I told you information about the square. I told you the area of the square, and you found the side length, and you find the perimeter, and you found the diagonal. We could have done the opposite. I could have said, all right, you got a square, and you know that this distance is 30. Okay, what's the perimeter, what's the area, what's the side length? And again, it's one of those things that if I tell you the diagonal is 30, then you know that the side length is the square root of 2 times smaller. We know we can rationalize this. That's 30 radical 2 over 2, and so then that's 15 radical 2. So you know that if the diagonal is 30, the side length is 15 radical 2. Well, then the perimeter is just 4 times that. Right, definition of the perimeter is just the distance around, and so you get 60 radical 2 for the perimeter. And then the area we know is the side length squared, so that's 15 radical 2 times 15 radical 2. 15 times 15 is 225. Radical 2 times radical 2 is 2. And then you get 450, and let's say that's in inches squared. Okay, makes sense? And it will turn out that the area formula also can be, instead of just side length squared, it's 1/2 times the diagonal squared. 1/2 times 30 squared would be 1/2 of 900, and you get 450, which is the same thing. At some point, maybe I could even show you that this formula comes from this fact. Maybe not today. Okay, so that was probably a good kind of square stuff, in that I gave you area and you found the side length, and then you found the perimeter. In this case, I gave the diagonal and you found the perimeter, and you found the area, and you kept everything exact. Okay, and you can do all these things, you know, with square properties. All right, let's do an example then with rectangles, and maybe I'll give you a little review of trig. So let's say a rectangle, let's just maybe do one of these. And let's say you know the diagonal is 10. And let's say you know that this angle that the diagonal makes with one of the side lengths is 35. Let's find the area and the perimeter, okay? Let's call this x and let's call this y. And just a reminder, we're gonna have to use trig here, okay? So we're gonna have to say then that if we wanna know x, remember SOHCAHTOA. All right, review back in your notes. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So we could say, all right, then we could say that cosine of 35 is x over 10, and this is the easy algebra, right? X is right where it wants to be. All I gotta do is multiply by 10, and I get that. And I can type that in on my calculator here in a second. So make sure I'm in the correct mode. I'm in degree mode, and I'm gonna do 10 cosine of 35. Oh, buddy. 10 cosine of 35, and I'm gonna get 8.2, and then I'm gonna do sine of 35 is y over 10, and I'm gonna do the same thing. I'm gonna get 10 sine of 35 equals y, so 10 sine 35, and I get 5.74. I don't know why I rounded. Let's just do 5.7 equals y. Okay, so I know x and y at this point. And again, it's one of those, if I know x and y, then I know the side lengths. So if I know the side lengths, I can do the perimeter. The perimeter is just 2x plus 2y, and then the area is just then x times y. So it's one of those things that if I know the diagonal, I can find the area and the perimeter, because if I know the diagonal and an angle, now if I just knew the diagonal, I wouldn't be able to do anything. If you just know the diagonal for a rectangle, and that's it, you can't do anything. But if you know the diagonal and an angle, or you knew, maybe you knew the diagonal is 12 and you know one of the side lengths is 4, well then you can find the other side length, because you can do the Pythagorean Theorem. Because you know if it's a rectangle that these are 90 degrees. And then you can find all sorts of stuff. Remember, if I wanted to find an angle, like this guy, and I knew those two sides, then I could use inverse trig. Remember, this is opposite, this is hypotenuse, so I would say sine of the angle is 4 over 12, and then the angle is then inverse sine of 4/12. So I could take second sine of 4/12, and I get would be 19.5. So I could find angles, I could find side lengths. Once I know x, then I could find area, and I could find the perimeter, and you could do all sorts of stuff. So just as a reminder, there's trig, there's inverse trig, and there's the Pythagorean Theorem, and you can find all sorts of information about rectangles and squares. Okay, I know the video was a little longer, but I thought I should go through some more examples. Hopefully this helps you with rectangles and squares.